So I'll start by introducing myself, and then my colleagues will introduce themselves. I'm Jackie Hildering. I'm coming to you from Port McNeill, where the Marine Education and Research Society is based. Where we learn and where we work is the territory of the Kwakwa-speaking people. Tonight, what my job will be is to smile at you, look accommodating, encourage questions, and also I am the technical support, which I'm really thrilled about within this. I'll come back to what my job is as technical support after my colleagues introduce themselves. And the first to do that will be Joanne.
Hi everyone. As Jackie just said, my name's Joanne. I am joining you from Vancouver right now. I am a MERS research associate. I recently graduated from the University of British Columbia, hence the master's night, and I now work for Fisheries and Oceans.
Brilliant. And then we have Ali introducing herself.
Yes. Hi, everyone. Thanks for joining us tonight. My name is Ali. Yeah, thank you so much for giving your evening. As Jackie and this night is about, I have been a research assistant with a research assistant with MERS associate. Sorry, that's the right word. I thought it sounded wrong for the past 2.5 years. Conducting and completing my master's on vessel behaviors around large whale species in the waters off Northeast Vancouver Island. I graduated from my master's in September, and now I work as the BC entanglement mitigation specialist for the Canadian Wildlife Federation. And I also wanted to take a minute to kind of introduce and situate myself. I'm an uninvited guest and second generation settler from British heritage. I grew up on the lands of the Mississauga, Anishinaabe, and Odawa people, and I'm incredibly lucky and privileged to work and live on the traditional, ancestral, and unceded territories of the Nuchalnuth, Kwakwaka'wakw, and Coast Salish people, specifically the Wewakai and Wewakam people of what is now known as Quadra Island. The work of my master's was done on Lekwungen and Wasanich people's land and unceded territory of what is now known as Victoria, and the lands and waters of the Kwakwaka'wakw-speaking peoples in the North Island. And yeah, with that in mind, the least I can do in return is to express the intention to use my place of privilege as a white woman trained in Western science to continue to learn and challenge myself and those around me, and to make a commitment to give back to the peoples whose land I live on by paying rent, so to speak, by supporting local businesses and initiatives run by the First Nations where I live and visit.
Hey, thank you so much. And I know, Joanne, you've got more of the place-based work within your presentation. And that brings us to my dear colleague, Felicia, who will introduce herself and launch into what our MERS Research Associate Program is.
Hi everyone, my name is Felicia Vachon. I'm the research coordinator at MERS. I'm currently tuning in from the unceded territory, traditional territory of the Qualicum First Nation and the traditional keepers of their land. And I'm here tonight, just like Jackie, in more of a technical support roles, but I wanted to introduce the Research Associate program that MERS is leading. So we are delighted to have two MERS Research Associates with us today, which are Joanne and Ali. The MERS Research Associate role is granted by MERS on a project-by-project basis for project that advances MERS's goal of furthering our understanding and conservation of the marine ecosystem through scientific research, environmental education, and marine wildlife response. Today, our research associate will present an adaptation of their master's thesis defense to highlight how their work help us further understand and conserve the British Columbia marine ecosystem. The master's defense is a culmination of 2 to 3 years of rigorous research. The defense itself is usually a 20 to 25-minute presentation, followed by 2 to 3 hours of question from a research committee, a research supervisor, and an external examiner. Today, we're getting an adaptation of those 20 to 25-minute presentation for the general public, and we're limiting the question to 10 to 15 minutes because I don't think anybody wants to be here until midnight. So without further ado, I'll lob it back to Jackie to talk about more the technical side of things, and then we can get started with Joanne and Ali.
Thank you so much, Felicia. So indeed, folks, we're probably all well seasoned with with Zoom. There is no chat tonight, as you may have noticed. We really, really welcome your questions. If you could please put them in the Q&A. I see that a hand is raised, and I'm afraid that we will not be unmuting and answering. So please, if that could go, that may have been accidental. But please, if you could put your questions in the Q&A. And then what we'll do is answer the questions at the end of both Ali and Joanne's presentations. So again, please use Q&A. That'll also serve if you have technical problems. You could pretend that's a question. If the question is specifically for somebody on our team, if you could mention their name within the question. And I think within all of this, and forgive me, I don't think I mentioned what it is I actually do. So usually I am not the technical guru for the Marine Education and Research Society. I'm one of the co-founders. I drive a boat, I look at whales, and I'm apparently the communication and education person. So with all of that in mind, I think we're at the stage of where we start the presentations and that we are still starting with Joanne.
Perfect. Let me just share my screen, make sure everything works perfectly. There we go. We can see everything okay? Amazing. Okay, well, as we just mentioned earlier, thank you so much, you guys, for joining us tonight. It's a pleasure for me to present about my thesis. The last time I did this was very stressful, so it feels good to be talking about it in more an educational perspective. And today I will talk to you about my project, which is look at humpback whale pre-consumption and the effects of a growing population on the food web in the northern Strait of Georgia. But before I begin, I would like to acknowledge all the people on the screen here who have helped in data collection, analysis, and interpretation. And this project would not have been a success without them. And therefore, for the rest of the presentation, I will be speaking as a we. I would also like to acknowledge that the lands and waters where I had the privilege of conducting this research on are the traditional, ancestral, and unceded territories of the Musqueam, Squamish, Tsleil-Waututh, and Comox nations who have cared for the lands and waters. And now let's talk about humpback whales. So humpbacks are baleen whales found in every ocean in the world, but today we will stay close to home and talk about some of the North Pacific humpback whales. North Pacific humpbacks typically feed in cold temperate waters at higher latitudes in the summer months before undertaking a long migration to lower latitudes for breeding and calving. And while in their breeding grounds, they are thought to feed very little or not at all. And since humpback whales are capital breeder, they need to build the energy reserves during the feeding season to sustain their migration and reproductive activities. And like many other cetaceans, sadly, humpback whale populations across the world and in the North Pacific were severely depleted by commercial whaling, which ended officially in 1986. And since then, the North Pacific humpback population has shown a significant recovery, with yearly growth rates estimated between 5% and 8%, but those estimates date from 2006. And so the reestablishment of humpbacks has not been consistent across all feeding areas, meaning that there has been a time lag between the end of commercial whaling and the reestablishment of the species in certain area, like the Strait of Georgia. And just for reference here, so obviously we have Vancouver Island in the middle, and the little star is Vancouver, where again I had the pleasure of conducting this research. And so after humpbacks were extirpated from the area, it actually took almost 100 years for them to come back. And so with a fairly recent increase in sightings of humpbacks, we chose the Strait of Georgia to study the implications of their recovery on a local ecosystem. But for this study particularly, we will only be looking at the northern part of the strait, which is here highlighted in blue. And so, as I mentioned before, humpback recovery is likely to have implications for the ecosystems in which they reestablish. And so a growing number of humpback could increase predation on prey species, leading to decreases in biomass in the species targeted. And in the North Pacific particularly, there's been some models linking humpback whale recovery and ensuing prey consumption that has suggested that humpbacks may be partially responsible for the failure of Pacific herring to recover. And so these results have raised questions about carrying capacity for the species. But most importantly, these models made a crucial assumption, and that is that humpback whales forage mainly on herring. However, in British Columbia waters, there is evidence of humpbacks foraging both on herring and euphausiid, as well as other prey species, but we don't know what the precise diet composition is. And so with that in mind, we aim to address 3 research questions. First, what is the contribution of each prey item to the diet of the humpback whales in the Northern Strait of Georgia? Second, what are the implications of their recovery on the Northern Strait of Georgia food web? And finally, what is the carrying capacity for humpbacks in the Northern Strait of Georgia? But for now, let's just focus on the diet. And so stable isotope analysis has become a preferred method for inferring diet in free-ranging cetaceans. I won't walk you through the entire process, but if you do have questions, just let me know at the end. And so stable isotope basically act as biomarker throughout the food web. And in marine system, we usually use carbon and nitrogen because carbon is an indicator of the benthic pelagic gradient, so where are things found in the ocean, and nitrogen is a proxy for trophic level. And so these different ratios of these 2 isotopes create a unique signature. And each species is thought to have this unique isotopic signature. And so the idea is if the signature of the prey is reflected in the tissues of the predator, so for instance, the humpback whale, then we can infer something about diet. And so this is really a case of you are what you eat. And the species that we chose for this study were adult and juvenile herring, euphausiids, as well as amphipods. And so with that goal in mind, we collected 108 skin biopsies from unique individual humpback whales over the summers of 2022 and 2023. Here on that beautiful map, you can see the different months highlighted in colors and different years with different shapes. And all of these biopsies were collected under Marine Mammal License, the research license, as highlighted underneath. But we also needed to obtain prey from the same area in order to compare those signatures I was talking about. And we were very fortunate to have been giving prey samples by Fisheries and Oceans, as well as the Pelagic Ecosystem Lab at UBC, and those values were used to complete our analysis. So prey samples were mainly collected from the Strait of Georgia, but also from other areas between Vancouver Island and the mainland. And then we sent all of these samples for analysis of carbon and nitrogen. So here, this is a classic stable isotope plot. On the x-axis, we have carbon. On the y-axis, we have nitrogen, which is again an indicator of trophic level. And the first thing we can see is that the stable isotope values of prey are significantly distinct, which is really what we want in a stable isotope study. And values of prey here are corrected for the trophic enrichment factor, which is basically the accumulation of certain isotopes through the food chain. And these were used as inputs into a Bayesian mixing model, which is just a fancy word for a complicated mathematical model, and that helps us in estimating diet composition. But the most important thing here that we see here is that there's a high overlap between the signatures of humpback whales and signature of euphausiids, which indicates that the euphausiids are an important component of humpback diet. And in fact, we found that during the summer months, humpback whale forage mainly on euphausiids and a little bit on juvenile herring. Now, I do want to emphasize that this is the first diet study ever done in the Northern Strait of Georgia, so it's kind of hard to find other studies to compare results to. But if we look in the past at analysis of stomach content of captured whales during the whaling period, our findings actually point to similar results. However, as I mentioned, it is a different time period and a different area, so there's a lot here that we need to take into consideration. If we compare it to a current study in humpback whales of Southeast Alaska, we actually find that the Northern Strait of Georgia humpbacks have a more specialized diet. Whether this is a result of a different prey availability or individual preferences, we didn't test for that. But acknowledging these differences in diet across the Northeast Pacific is really important to study the influence of humpbacks on the food web. And because our biopsy sampling season ran across multiple months over the summer of 2022, we also decided to test whether there was monthly variation in diet. And so here we use the isotopic niche space as a proxy for ecological niche, and with the belief that if there's changes in the isotopic niche space, then that would indicate prey switching. However, as we see here, there's sort of a lack of trend with a really high overlap between the isotopic niche, which is shown in the different colors here, indicating to us that the diet remained relatively stable. But if we look at the breakdown of the mixing model result, we can see that the contribution of euphausiids actually seems to increase from July to September. Yet, because of the large confidence interval that you can see around these estimates, we can't really say that this is for certain a shift in diet, and so it would be need to be investigated further. And so that answers our first research question. What is the diet composition of humpbacks in the Northern Strait of Georgia? Well, during the summer months, they feed predominantly on euphausiids and juvenile herring. And now we can look at the implications of their recovery on the food web. So ecosystem modeling can be a very useful tool to assess food web dynamics. And in this study, we use this amazing tool, which is called EcoPath with EcoSim. And so basically, EcoPath takes a static snapshot of the ecosystem at a certain point in time, and EcoSim adds a time dynamic simulation that allows us to predict changes in species biomass in response to a driver. And again, I was very fortunate to be able to use a previous Strait of Georgia model for this research, which was built by one of my lab mates, Greg Altford. And now bear with me while I'm going to try to walk you through ecosystem modeling. So as I said, we have these two components, the static snapshot, which is EcoPath, and then the time dynamic simulation. And so we took the original model, but since it had a larger spatial scale where it covered the entirety of the Strait of Georgia, we had to simplify it to fit our smaller study area. And since our main research question regarded humpback whales, we really wanted to have the most precise estimates for the individuals that were feeding in that area. And so we used the diet composition inferred from the stable isotope analysis, which I talked earlier. And then now that we knew what they were eating, we needed to know how much. And so we combined the diet composition with the prey energy density, and using new mass estimates that we inferred from photogrammetry, so drone footage of humpbacks in the Strait of Georgia, we combined all of these into the energy prey requirement, and that gave us estimates of consumption rate. And then we needed to know how many whales there were. And so we calculated current humpback whale abundance estimates from bug-based surveys that took place in the summer months of 2022 and 2023, so the same years that we did our sampling. And finally, we were able to simulate the implications of humpback recovery by forcing the biomass of the species in the ecosystem model. Now, just a quick note, I used both the terms biomass and abundance. Ecosystem modeling typically only takes in biomass into consideration, but we recalculated everything into abundance just for simplicity when we talk about the whales. And so what did it actually look like? So from our surveys, we know how many whales there were in the summer months only. But since humpback whales migrate in and out of the system, we took a yearly average, and that gave us about 125 whales. We also know that sightings of humpbacks prior to the early 2000s were rare. And so we linearly increased the number of whales from 2000 to 2022 until our current abundance estimate. And now we can look at our projection. So we continued increasing the number of humpbacks using a staircase approach. That means we titrated the number of humpback whales with periods of no change in between to let the model stabilize. And we started with largest increases that got smaller and smaller as time progressed. And if we look at our initial increase period, so from 2000 to 2022, just one, we can see that all prey-species biomass remain relatively stable, indicating that thus far, humpback recovery did not have a significant influence on its prey. And if we look at our projections, we can see a slow but sustained decline in adult herring, juvenile herring, and euphausiid biomass as humpback whale abundance increased. However, as we can see here, adult herring appear to have a more important decline in their biomass. And another thing that is important to realize here is that that decline became more prominent when humpback whale abundance reached 180 individuals. This is a very hefty slide, but I will talk you through it. So on the right here, we see a mixed trophic impact plot that is generated by the ecosystem model that we use. And it basically depicts the relative impact that humpback whale had on other species in the model. And that is throughout the entirety of the simulation. So on the y-axis, we have all of the different species and species grouping. And on the x-axis, we have time. And the dashed line indicates the year 2022, when our projection simulation began. And so first we can see that humpback whales negatively affect juvenile herring, euphausiids, and adult herring. But if you recall the previous slide, it looked like adult herring were more rapidly declining than the other prey species. But in fact, that mixed trophic impact plot actually shows that humpbacks are not the sole driver of that decline. We also see some weak positive and negative relationship between humpbacks and other prey species in the food web, but nothing really stands out, indicating that humpback whale recovery overall had minimal cascading effects on the food web. And the last thing I want to point out is that as the simulation progressed, humpback whales started having a more negative impact on themselves, which is usually a sign of intraspecific competition, which can be an indicator that a species is nearing carrying capacity. And so the main takeaway of this portion of ecosystem modeling is that humpback whale recovery mainly affects prey species, but had minimal cascading effect on the food web. And now we can look at carrying capacity. And so how do we estimate carrying capacity using ecosystem modeling? The best way that we thought to do so was by looking at the point when the main prey species collapsed. So that was both euphausiids and juvenile herring. And this is usually an indicator that the food web can no longer support the next increase in humpback whale abundance. And in our model, we estimated the carrying capacity to be around 388 individuals. But I really wanted to frame the uncertainty around this number because we can't just say 388, that's it. So we wanted to, frame the uncertainty. But the way that we set up our initial simulation wasn't appropriate to do so. So instead of having large increases followed by smaller increases in humpback abundance, we reverted to a more simplistic approach with smaller but equal increases in humpback abundance. And we ran 1,100 Monte Carlo trials, which are testing the parameters in the model, basically to test that uncertainty and determine the minimum, maximum, and average population size that caused the main prey populations to collapse. And from that, we estimated the carrying capacity to be around 417 individuals, but anywhere ranging from 372 to 478. But if we look at the mean population size of humpback that caused the collapse of prey separately, we actually noticed that humpback whale carrying capacity was lower when looking only at euphausiids, which suggests to us that euphausiids may be the limiting factor for humpback whales. And a few points that are important to discuss here is that the estimates of carrying capacity is a year-round average, meaning that the number of humpbacks could actually be higher or lower depending on the season. We also noticed that the population trajectory model influenced our carrying capacity estimates. So suggesting that larger and sudden increase in predator population actually decreases the carrying capacity for the species. And finally, the most important takeaway perhaps is that the carrying capacity that we estimated with both methods predicted that the ecosystem can support a population that could be 3 times larger than the current abundance level. But there's a few caveats also to discuss. And first is that this is a simulation, not a prediction. We are in no way saying that this is going to happen and in that number of years. We also did not take into account any environmental factors like climate change. And we know that climate change may affect prey availability for humpbacks, so that could decrease that carrying capacity estimate. The carrying capacity that we presented here is a maximum number of whales that can be supported by the current food web, but carrying capacity is also a density-dependent factor that should take into consideration habitat use. And the northern Strait of Georgia humpback still face a great number of anthropogenic threats such as vessel strike and entanglement, which could affect the survival of individual humpbacks. And so in this study, we presented new estimates of diet composition for humpbacks, suggesting that they feed mainly on euphausiids and juvenile herring during the summer months. We also demonstrated that their recovery had the strongest implication for prey species, but minimal cascading effect on the food web. And we estimated the carrying capacity to be between 372 and 478 individuals, which is 3 times higher than the current abundance estimate. But we really wanted to emphasize that using this novel empirical data from stable isotope to estimate diet, distance sampling to estimate abundance, and photogrammetry to determine whale mass, which play the role in estimating consumption. And so having these local estimates gives us more confidence into our ecosystem model result. And we hope that this study will help inform conservation policies for humpbacks, but also contribute to the efforts in determining their ecological role in our ocean. Finally, we want to address a common limitation for both the diet study and the ecosystem model, and that is seasonality, because seasonality dictates productivity and prey availability. And although humpback whale abundance is highest in summer and fall, individuals have been sighted in the area during all months of the year. So we cannot exclude that prey switching may occur in winter, which could affect our model's prediction. And we hope that future research will look at those seasonal differences in diet to inform ecosystem model. But we would also like to see more studies looking at regional differences in diet and ecosystem structures in British Columbia, but also in the North Pacific. And to finish this presentation, I would like to thank again everyone who has helped in this project, my supervisor, Dr. Willie Christensen, my supervisory committee, Dr. Sheila Thornton, Christy McMillan, who's also part of MERS, and Dr. Brian Hunt, and MERS who have helped fund this research, but also provided so much crucial knowledge about humpback whales throughout this study. Thank you.
Thank you so much, Joanne, and thank you. It's wonderful to see the questions come rolling in. A reminder that we will answer the questions at the end of Ali's presentation. And please, other than the specifics of the research, we're very happy to answer questions about our choices in partnering with research associates And also, I'm sure that Joanne and Ali would love to talk about the whole master's process as well. But without further ado, Ali will now give her master's presentation.
Sorry, classic, forgot to unmute myself. Just checking that you can see everything okay. Good, okay. All right, hello again, everyone. That was great to hear from Joan. I haven't heard her speak on that since we were both very preliminary in this project, so it was great to see the final results. Yes, so to give my master's defense, again, like Joan said, the last time I gave this talk was much more stressful, so it's really nice being in the comfort of my own home in a much more relaxed setting. So yeah, this research I conducted and completed this to look at vessel behaviors around cetaceans or large whale species in the waters of Northeast Vancouver Island through the lens, the theoretical lens of social influence, which I will talk about very soon. And this research would not have been possible without my wonderful co-authors listed here and all of our collaboration with the Marine Education and Research Society, the Applied Conservation Science Lab at UVic with Chris Terramont, who I did my master's through, and members of the Raincoast Conservation Foundation. So most of us have had the experience of driving down a road, seeing someone stop ahead of you and pull out their camera to take a picture of something you might not be able to see. Maybe you can see rustling of some bushes or hear a bird song. But what do? Do you keep driving, or are you curious and stop, take a look, and maybe pull out your camera too? What if it's an animal you've never seen before, or an absolutely crazy situation like this? When you make decisions taking cues from people's behavior, whether it's following a crowd of people taking pictures of a bear, signs in the park, or simple trail markings, these are all under the umbrella of a broader theoretical framework called social influence. And the effect of social influence on our behavior has been studied for decades in many fields, including social psychology and law. And there are different aspects of social influence that can affect someone's behavior, with two of the main processes, including the influence of existing regulations or law, like deciding not to fish in a marine protected area, maybe by seeing signage or existing enforcement that's present. And the other way is observing and taking cues from other people's behavior. So this is particularly important when we're unsure of how to behave in a situation, as illustrated in Aldridge et al. 2023, where a fisher may be strongly influenced into non-compliance, so fishing in an MPA when you're not supposed to, based on seeing others fishing in an MPA, especially a group of people who appear to have no repercussions for their actions. And while social influence has been well studied in other research fields and feels quite familiar in real life, there has been little work done to quantitatively test and examine human-wildlife interactions in this scientific context. So, can we see both rule-based and social influences play out on the coast, where being on the ocean, looking at iconic sought-after species, and confusing regulations are being combined? And to address this, we wanted to understand the behavior of boats around marine mammals. So studying human-marine mammal interactions are critical as globally increasing vessel traffic and the fortunate return of many cetacean species from industrial whaling and extractive practices. There are more whales and more vessels, which means there are simply just more interactions between cetaceans and vessels happening, increasing disturbance to marine mammals that impact behavior such as foraging with vessel noise, and the rising concern of harmful or fatal ship strikes. And examining these interactions is critical for conservation, yes, but also for boater safety. Two strikes happened in the summer of 2024 near Port McNeill, one where a calf named Auger was hit by a boat, and as far as I know, no one was hurt, and the calf was suspected to survive from this post by MERS. But as you can see, there was some serious damage to this boat and injuries to the calf auger as well, and it could have been a lot worse. And many at-risk species of marine mammals have critical habitat in the middle of busy traffic zones in BC, such as the Johnston Strait region off Northeast Vancouver Island. Here, there are a high density of vessel traffic through narrow straits, navigating through islands and channels, and high levels of biodiversity with large cetaceans such as humpback whales and 2 ecotypes of killer whales. And humpback whales and killer whales are ecologically, culturally, and economically important species in BC, where people travel all over the world to see these beautiful, iconic animals in their natural habitat. They are also species at risk with critical functions in their ecosystems, and they're just really beautiful to witness in this environment. So, because of all this, there have been national regulations created to mitigate human behavior around marine mammals. Now, this sign is great, and it's regularly advertised at marinas, but these regulations depend on boater knowledge of species, how far they are away, and what this distance looks like on the water. And the regulations vary by what region and country you're in. And there's very little known about whether people follow these regulations, let alone how they behave around whales in other ways. And as I've been talking and you're trying to read all this text and you got a bit lost, this is the problem. These regulations can be very confusing to boaters, with many people not even knowing they exist. So this leads us into our first objective, to ask how compliant are vessels to the national regulations off Northeast Vancouver Island. And in this region, the distance regulations outline a minimum avoidance distance of 100 meters from humpbacks, 200 meters from humpbacks that are resting and or are with a calf, and 200 meters away from killer whales. And in this little picture of what it may look like in a day of sampling, we predicted that compliance with national regulations would be lower in vessels that may not know the existence of these regulations or the specifics of them, which is most likely to be recreational vessels, or that compliance would be lower with sought-after species like killer whales. And we conducted this study over 3 study sites within the region where there are known confluences of boater and whale density, thanks to the local knowledge of namely Jackie and the team at MERS. And so a typical field day looked like this, where scans were completed with laser rangefinders from land. And in the summers of 2022 and 2023, we conducted both 10-minute hourly scans, so every hour on the hour, and opportunistic focal follows, where we followed one individual whale through the focal study area and to track what a whale encounters within that area. To assess compliance, we only considered vessel-whale interactions up to 500 meters, and this was to be comparable to another recent compliance study done in the Salish Sea, which I'll touch on later. So with 475 hours of scans under our belts and 405 whale-boater interactions, we can see some results. On the y-axis, we have the density of observations, where the top of the axis is just the most frequent observations seen. And on the x-axis, the distance to compliance. So these have been scaled to each species and their respective regulations. For example, if a boater was 100 meters away from a humpback, it would land on the 0 meters on this graph, or 0 meters from the regulation distance. And if a interaction was non-compliant, it would be on the left of this line, and if they were compliant to the national regulations, it lands on the right. So this graph is both of the species pooled, with the mean distance here in the colored dashed lines. And we saw a high overall compliance of 86%. And it was also interesting and great to see that both ecotour and recreational vessels had high compliance, with 87 and 85% respectively, showing no significant difference between vessel types. And this indicates that there is a high level of awareness of the regulations, even in recreational boaters. And this points just to, this could indicate how important education is in these areas, which I'll touch on a little bit later as well. And breaking it down to the species level, there was significantly higher compliance in humpbacks than in killer whales, where almost 1/4 of interactions we observed were non-compliant. And both of these results are surprising, particularly the high compliance rates to humpbacks, as they are newly recovered to this coast in the last 10 to 15 years, post the whaling period. Boaters are less used to navigating the whale waters with them. They are generally less educated on a kind of coast-wide level, and they are more unpredictable in the water, and not to mention just a lot bigger. So yeah, they may present more risk in vessel strikes to them and boaters. On the other hand, the high non-compliance rates with killer whales are interesting and as I said, somewhat expected in our predictions. It makes sense as they are the most marketed species in marine-based nature tourism, but also as most of the education funding and conservation efforts are directed towards this species, and people are still getting closer to them. And further breaking down this overall humpback compliance into the two different regulations, where boats had very high compliance to the 100-meter humpback regulation, but significantly lower compliance to being 200 meters away when humpbacks are resting and/or are with a calf, particularly amongst recreational boaters. And again, this makes sense where recreational boaters that may or may not know that this rule even exists, they also must be familiar with humpback behavior and what a calf looks like. And these compliance results are super interesting, namely comparing to a recent 2020 study by Molly Fraser and team, another past ACS student and affiliated with MERS as well. We saw that the Northeast Vancouver Island had higher compliance than the Salish Sea. And the most striking differences between our project, these study results, is that we found no significant difference between vessel types, yet there were prominent differences found in the Salish Sea between commercial ecotour and recreational vessels. We suppose this is mainly due to much more complicated and complex regulations and vessel density, including additional distance laws, speed restriction zones, and regulations changing once you enter US waters, which is easy to do in the Salish Sea. And past studies such as Weaver 2013 and Roy 2021 have illuminated these associations with regulatory complexity and public confusion, leading to lower compliance. So this leads us to our second outcome in question. We wanted to look further into these vessel-whale interactions past the regulations. So namely, what characteristics of people and wildlife influence boater behaviors around a marine mammal. Now, we conducted 3 different model sets with multiple associations. So if I presented every single result, I would be talking for a lot longer than I'm supposed to. So I'll only speak to the most striking patterns and the ones that matter the most to policy and education outcomes. And to explore these interactions more beyond regulations, we assessed boaters within 800 meters of a whale. So we opened up that radius of our data set and only within those focal scan interactions where we're tracking one whale at a time. And so when looking at these interactions, what behaviors can we actually observe from land accurately? So the clearest metric is a boat's distance to the whale, as these as this behavior already has regulations surrounding it. But what about non-regulated measures, like the number of boats around a whale and the time an individual boat spends around a whale? We conducted models called mixed effects models, and this examines many predictors at the same time that may affect boater behavior. It essentially builds an equation that best fits these, what we call response variables. So distance, number, and time are our 3 different response variables. And we expected to see elements of social influence come up with these 3 response variables. Where a boater may be aware of another boater's behavior, such as through radio communication and the number of vessels surrounding a whale. And we predicted that in these contexts, there would be 2 alternative responses, what we call a two-tailed response, where boaters would elicit more pro-environmental behaviors or encourage the opposite. And we also predicted that context-specific variables like vessel type or vessels that are more likely to view whales, like ecotour vessels, and more context-specific variables like species, particularly ones that are sought after, like killer whales, or sought after behaviors like surface behavior, so breaching, peck slapping, tail slaps. And we predicted these would result in boaters being closer to whale, more boats, or spending more time with a whale. So into our first response variable of distance to whale, I'll walk through these models as there's a bit to unpack. So on the y-axis of this response, which is the distance to whale, and you can see that these variables are affecting vessels beyond the minimum avoidance distances. So it's going up to 500 meters, which is beyond the regulation. But we can see striking patterns when we include these, and we see that the time a vessel spends with a whale is influences the distance to whale. And to walk you through what we might see, if the line starts up in the top left corner and ends up in the right corner, bottom corner, this would mean that that when boats spend a longer time with a whale, the more likely they are to get closer to that whale at some point within that time. And we can see that this is exactly what happens. So the more time a boat spends with a whale, again, the more likely they are to be closer to that whale at some point within that time. So at some point within the 30 to 40 minutes. And we can see an association with the average number of boats as well, where when there are more boats around a whale, they actually stay farther away, illustrating that maybe the mere presence of someone else can affect our behavior. And to move on to our second response variable of the number of boats around a whale, so we're switching this one to the y-axis. We have the number of boats within 800 meters of a whale. And the most striking pattern revealed a relationship with the communication on a VHF radio channel on a public channel that is intended for the local whale watching community to share whale sightings and alert boaters to a whale if they're logging or kind of hard to see, and marine mammal issues of concern like an entanglement. And we saw that whether this communication was present or not within a focal scan was associated with the number of vessels. And this revealed that there were more vessels present when there was radio communication present during the focal scan. And finally, our last response variable of the time a boat spends within 800 meters of the whale was influenced by how close it was to the whale. And we can see this is basically the inverse of the first figure I showed, where the farther away a vessel is, the more likely they are to spend less time with the whale. So this is pretty intuitive, as vessels that are staying farther away, like 800 meters, they're likely just transiting through and not really paying attention to the whale. But this may indicate the factors of social influence and those pro-environmental behaviors may decline the longer a vessel spends with a whale. So in other words, the longer a vessel spends with a whale, they might be less influenced by the number of boats around them and other kind of social influence factors. So over these 3 metrics of boater behavior, we can see that actions of other surrounding boaters may change the distance, number of boats, and the time they spend with a whale. Another surprising result is that in these models, really the species characteristics did not show up as significant, and this was also surprising. And particularly that the number of vessels present and the time spent with a whale were important variables to consider, and using them in education could potentially result in eliciting pro-environmental behaviors, potentially helping to mitigate disturbance, the risk of strikes and noise disturbance. And as I mentioned, our results also present very interesting trade-offs between awareness and increased disturbance. So as we saw, radio communication may be associated with more vessels around a whale, but radio communication is a really valuable tool that alerts the appropriate people to a marine mammal issue like an entanglement, or is a really valuable education tool. And we also saw another trade-off where potentially when there is more boats present around a whale, they actually stay farther away, which is an important trade-off in itself. So these models have several limitations, but one of them, it just alerts you to the association, but can't actually say any more about it. So these trade-offs and associations need to be further studied, and their implications and possible conservation gains need to be studied in subsequent research. And through this project, we developed a better picture of how boaters are responding to these regulations. And in Northeast Vancouver Island, that there is high compliance, but regulations and compliance that depend on boaters to know specifics about whales may lead to less compliance to the regulation. So we suggest, along with the call of other studies, that simpler regulations, such as creating one avoidance distance regulations for each species and across regions, could increase further compliance and understanding of regulations. But they are complex for a reason. There's many nuances and conversations to be had with this as well. And we were able to see that compared to other studies where people were influenced into non-compliance, like Aldridge et al., we also saw that with numbers, they can be influenced to go above and beyond the regulations. So yeah, way beyond compliance and into pro-environmental behaviors. We suggest that social influence can be used as a useful tool to leverage in both policy and education. So a clear option is to prioritize education, particularly in areas where regulations are more complex. And VHF radios could be used in ways to shift people's behavior in pro-environmental ways, and education could focus on encouraging boaters to share what they know. As we can see through our results, that even if a few people act safely around the whales and that behavior is seen, the rest may follow. And this project has been a huge collaboration with MERS and will be further used in potentially in their education campaigns, such as See a Blow, Go Slow, sorry, and a province-wide boater course that is coming sometime soon to provide education and knowledge to navigate safely around marine mammals for recreational boaters. And more broadly, this project aims to provide a framework to understand human-wildlife interactions in more depth and can provide useful information for utilizing theories like social influence in effective management of threatened species and systems. And yeah, thank you. I'd like to thank my supervisor, Chris Darramont, for his support and supervision for this project, our wonderful partners at MERS, and my experience with them as a research associate has been fantastic. My committee members and all of our collaborators and funders, members of the lab, and everyone at this webinar right now. Without all of you, this project would not have been possible. So thank you.
Yay, thank you, Joanne and Ali. Aren't you, this was lower threshold than when you had to do it for your defense, wasn't it? So please, folks, have the questions come rolling in for both Ali and for Joanne and for Felicia and I as well. We will address a few. Felicia and I will go back and forth. Not surprisingly, there's more for Joanne right now, since there was a longer period since your presentation. From Grace, suspect we know which Grace. Joanne, did you find any completely unexpected isotope signatures in your samples?
Not completely unexpected, I would say. We in that graph that I was showing the overlap, there was like many points, and that forms the isotopic niche cloud if you want, and there was no major like outlier that was way weirder than everyone else. So no very unexpected signatures, and if we did, we reran the sample and then it fell in line with the others.
Yeah, and then not surprisingly, Joanne, and I think I will chime in here from a Canadian Pacific Humpback collaboration perspective as well. Jennifer is asking, how many humpbacks are there now in the Northern Strait and how many in the whole Salish Sea?
Yeah, great question. Jackie and I were just talking about that last week together. So I can only talk about the Northern Strait of Georgia, because that's where we did our surveys, and that was already 2 years ago. But in that area, as I said, we estimated a yearly average of 125. But in the summer months alone, there's an estimated 120. And there's like different, there's Christy McMillan who does the abundance data for the Southern Salish as well. She estimated that there's more whales in the fall. So then we sort of have to take all of these aspects into account, the fact that there's different number of whales at different seasons. But again, that is only for the northern part of the strait. And then Jackie will probably tell you about the wonderful work they do with Tasley as well for the whole Salish.
Yeah, and thanks so much, Joanne. Just wanting to emphasize, since in my communications role, I know how often we get asked, people want to know a number of humpbacks that are in the Salish Sea or that are in British Columbian waters, and there isn't a reliable estimate. Joanne referenced Tasley Shaw is one of our research associates and is valiantly pulling all the humpback data from people, ecotourism operators, tourists, people on land, to actually identify the number of individuals that were sighted in the southern part of our province. But again, we're already there. We're talking about a different area because it's not just the Salish Sea where Joanne was. It's also Southwest Vancouver Island. And Tasley had an estimate, for example, Tasley is still processing her data for the number of individuals, as is evident by photos of individual whales, that at one time or another in all of 2024, there were 460 humpbacks, again, in a bigger area. But even for the whole province, there isn't a reliable estimate. Christy McMillan and Fisheries and Oceans Canada doing line transit surveys allows there to be a better estimate over time. But for example, for the whole province, including offshore waters, there's only been one survey that was done, not looking at individuals, but looking at the modeling of how many were seen under certain conditions. But that one estimate was done right at the end of a marine heat wave, whereby conditions were really, really variable, which is a point that Joanne has made as well. So, sorry, I went on for a while there, but the way that it works is Tasley, 460 plus in 2024, but it's a bigger area. And what Tasley pulls together then feeds into the Canadian Pacific Humpback collaboration. And Felicia will talk about some of the projects that we're working on there that Joanne's actually helping with. And we coordinate the Canadian Pacific Humpback collaboration. So that might have led to more questions being asked. I do think that I will trigger Felicia here actually, because a couple of the other questions are associated with this, Felicia. If you could ask the question about the region, about the results being from the Strait of Georgia, just to emphasize that.
Yeah, absolutely. I'll ask one more question to Joanne relating to this, and then I have some questions for Ali as well. So we are seeing those questions. I keep them coming. So yeah, Joanne, your results are from the Strait of Georgia, but can you comment on the importance of studying different areas relative to what MERS and, as Jackie mentioned, the CPHC mention, with knowing about like different feeding strategies in different areas?
Yeah, I think for me, it's something that is so close to my heart. It's like one of the reason why I was so interested in this project is that we are seeing like just the feeding strategies alone are very different around Vancouver Island. I was very privileged to be in the field with MERS and with Fisheries and Oceans, and yeah, Nord Island. We see a lot more like lunge feeding, which we weren't seeing in the Northern Strait of Georgia. And that's sort of how we came to this question is like, if all of these models say they feed primarily on herring, how are we not seeing these feeding behaviors in the specific areas that we were? So that's how we're like, well, what if there's difference in diet, or is it individual preference or individual behavior? So that's what sprung the question, and I don't remember the exact wording, but I hope my point is that I believe it's incredibly important to hopefully look at these different diets around Vancouver, southern British Columbia, and as well northern BC would be amazing to look at as well.
Thank you so much, Joanne. I have a question for Ali from Michael O'Leary. How did you control for vessels that were powered off? Were you using AIS or video or photos and position tracking, marine current charts over duration of time? So how did you deal with vessels that were powered off during your observations?
Yeah, so no fancy technology. It was me and some research assistants sitting on land viewing whales ourselves. So not with well, we didn't use AIS because so many recreational vessels don't use it. So we would be missing a large swath of vessels if we only used AIS. And so for vessels that were powered off, we had a kind of a variable of vessel speed. So we had idle vessels within our models as well. And they were put into our models. And yeah. So it was all just visual scans. Mm-hmm.
Hey, I'm going to grab one here again, throw at Joanne. So Nadia asked for defining carrying capacity, and are you referring to how many humpbacks the environment can support?
Thank you, Nadia, for this question. I read it earlier and I was like, oh, I should have made that clearer. So in a broad term, yes, carrying capacity is defined as the number of whales or the number of individual species that the environment can support. But in my study, it was mainly looking at how many whales could feed in that area and did not take into account the habitat use, because obviously there's going to be parts of the waters that humpbacks won't be able to go, or that are too too much boat activity or anything like that. So it doesn't take into account habitat use, which should be definitely considered. But yes, that's how I define it myself.
Not surprisingly, so as a follow-up question, there's questions about herring. How did that come about? So Helen Davis is asking, do Joanne's results mean that the humpbacks are most greatly affected by availability of juvenile herring, and therefore fisheries on juvenile herring could be having a great effect? Maybe the herring fishery shouldn't be increased or should be decreased.
Yes, fisheries. A lot to unpack. I didn't look specifically at the impact of or the interactions between fisheries and And humpbacks, because Jackie and I have discussed this last week, I was like, oh, that means the number of fish that's available to humpback, but there's also the other side, that is entanglements and everything that comes with that activity. The research that my findings mostly showed that it mainly is the euphausiids that are a limiting factor. And then the second part of your question is, yeah, the fisheries on juvenile herring, technically the fisheries target mainly adult herring. But again, as we know, there's like, if you decrease the adult herring, you decrease the number of offsprings they're going to have, which there's that entire cycle to take into consideration as well. So it's a straightforward question, but it never is a straightforward answer. And then there's always that other part as well, that the prey availability and climate change aspect as well that needs to be taken into consideration. But it's definitely something that should be thought about by decision makers, I would say.
And to add a bit of fortification behind this, why were we involved with these projects? Ali's project supports what we also got as feedback and input from over 4,000 boaters who filled in our boater survey to inform the whale safe boating course that we are developing free online, soon to come out in the spring. And in Joanne's case, this is a step to showing what we observe is that humpbacks have site fidelity. They're not all feeding in the same way, in the same places. And this is a key environmental piece. If the idea is that humpbacks are blundering around the coast with their mouths wide open and that they can feed equally well on prey in different areas. So it's a huge conservation piece for us to understand. Ali, I'm going to throw this one at you and know that I will back you up on this one. Yeah, so from Todd, do you know or understand how the distance in regulations was determined? On a boat, it is nearly impossible to determine 100 meters versus 200 meters. Why not expand it to 500 meters across the board? For instance, in Blackney Pass, a reference to Northeast Vancouver Island, more than 100 meters is an impossible separation between a vessel and the whales there.
Yeah, great question. Also not a simple answer. So, and I will be relying on Jackie to back me up on this as well. Yeah, it's a very complex and tight line to balance on creating regulations, and I was not involved, and this was much before my time when these regulations were created and amended, and so I understand that it's a kind of a tight balance of what is reasonable to expect from boaters and what what is reasonable to regulate, essentially. For example, having, I don't know, to widen it out, having a whale watching boat be regulated 4 kilometers around a whale is not reasonable to expect. So there's that piece, but there's also a piece of what is biologically relevant to the animal, and what vessel activity is important to consider when what is the biological relativity of that animal? What distances affect their sex-linked characteristics, their noise disturbance? So many things go into these regulations, and obviously I wasn't there when these regulations were created, but there are many conversations around what should happen. Why not expand it to 500 meters across the board? That may not be relevant across all regions, and that is being talked about, not specifically 500 meters, but what are the pros and cons of making it too simple, essentially? What are the pros and cons of, is there biological relevance to every species across every state?
I'm jumping in, Ali.
Yes. Yes,
So the Marine
this
Mammal
is
Regulations,
a longer answer that is...
so I'm jumping in because this
yeah.
is the joy of what I get to
Yeah.
deal with in terms of boater education. So the Marine Mammal Regulations are national. Up to 2018, there were no distances specified as minimum avoidance distances. So that changed in 2018. It is 200 meters for orca. 200 meters for orca, 200 meters for other species if with a calf or resting, and 100 meters for other species. And then there's another layer, which is not the Marine Mammal Regulations, but the management measures for the southern residents, where from Cape Mudge around to Ucluelet, it is 400 meters from orca, except if there's a purple flag. Yeah, so 200, 100, 400 changes by species, location, area. If this were just about the welfare of the animals, it would be one distance. And there's also a push for having it changed to 1,000 yards from all orca. So the reason that there isn't just one uniform distance is because human stakeholders have been considered against the needs of the animals. And this is like excluding geographical limitations and whatnot. The Marine Mammal Regulations are again under review. Those of you who helped with our boater survey have allowed us to present, as does Ali's research. Look, even boaters who are who want to do the right thing are sometimes confused, and this is why. That still puts the onus on boaters that they need to know the distances. Can't claim that, yeah, I didn't know what speed I was supposed to go through a school zone because it was complicated. It is still the law, part of the privilege of being a boater. Our online boater course, Whale Safe Boating, will address all of this. We do have distance estimator carts and also other means by which you can help estimate the distances. There's one fisheries officer who has up in Prince Rupert is having the breakwater measured out so that people can visualize what 100 meters is. So yes, it's difficult, and it's difficult because human needs are weighed out against the animals' needs, but that is no excuse not to be compliant with the law. And our Whale Safe Boating course will help you. Felicia, lob out the next one.
Absolutely. Speaking of killer whales, we have questions from Grace for Ali. Was there any indication that the presence of killer whale in the study area reduced the number of vessels around nearby humpbacks? And did you see differences between Big's killer whales and northern resident killer whales?
Great questions, Grace. If I know which Grace it is, hi. And a bit of a complicated one with the models with the mixed effects models, where it kind of gets into those more nuanced picture of what's happening. We were only able to use the focal scans, so that's including like when you're tracking one humpback at a time through the area. And so those focal scans may not, when we're only taking data on one whale, if there are residents a kilometer away, that isn't taken into account in those focal scans, although it is in our broad kind of 10-minute hourly scans. So in the models, no, that didn't show up, but that's kind of the limitations to these models, is they have kind of tight constraints of what you can include. And for Bigs and residents, kind of the same issue of well, a little bit different, I guess. For the models, you have to have a certain number of observations, and alone residents and big killer whales weren't kind of enough to have weight in the models. And so we had to pool them together. Although now thinking of it, the compliance results were still pooled, and we didn't separate them out, although we could, I guess, now that you bring it up. So great question. But yes, of what I've seen, no. But that is not to say there's not, I guess. And thank you, Jackie, for reining me in on the last question. This is why you're the educator.
No, I know the misery, believe me. And you weren't there, and we didn't decide the distances.
A question now for Joanne regarding sampling. Are humpback whales' fecal samples also studied to help determine what the majority of humpback prey is?
Becky knows this is my favorite question. I read it, I was like, Not in the study that I have presented. However, we have been working very hard to collect poop, and we are poop enthusiasts. And hopefully I know it sounds so odd at the dinner table, but it is what it is. And so there has been samples that have been sent for prey DNA analysis, and hopefully we'll see those results come back too. But just from a fully observational point of view, I can tell you that in the northern Strait of Georgia, all the poop that I have collected is bright pink and bright pink. So it sort of, for me, it creates link in my head. Now we have to wait for the prey DNA to come back, but yeah.
And bright pink, folks, is krill. So the
yes.
is showing us, just to make that clear. But also, please take up contact with us if you too would like a t-shirt, bamboo, locally made, that says "We are poop enthusiasts."
I'm seeing a comment from Helen saying that all biologists are poop enthusiasts, and I can agree with this one. And while we're on the subject of poop, Joan, do you want to comment on like humpback whale poop and its role in the ecosystem?
Absolutely. Yes. So as I mentioned, I didn't have time here, but the one thing that my research, I think, focused on is in the ecosystem modeling part is what they take, so what they eat, but it doesn't consider everything that the humpbacks give back to the ecosystem. And one of them is poop. If you think of the whale, it feeds, krill is mainly at the low, like at depth, so it feeds at depth, comes up, and then it leaves these beautiful pink poops for us. And then that re-sprinkles. So it always participates in the nutrient cycling as well. And that is one of the many reasons why I think conservation of humpbacks is so important. But they do participate in the nutrient cycling and the microbial loop of the ecosystem as well.
Pink poop, silver poop, all the poop, always at the
All
surface.
the poop.
Yeah.
Well, I'll take it.
Awesome. Thank you so much, Joanne. A question for Ali now. Wondering if there are any significant differences in social behavior and compliance depending on the type of vessel noted in the focal scans.
Any significant, sorry, I was trying to, any significant, can you read that again?
Yes, absolutely. This is a question from Jackie. Wondering if there was any significant differences in social behavior or compliance depending on the type of vessel noted in the focal scan.
And not this Jackie, Straight Watch Jackie.
Yeah, Jackie Martindale.
Yes. Okay, yes. Thank you for repeating that. There were, no, they didn't show up in the model. And again, there are limitations to these models, but compared to a bunch of other factors, vessel type did not show up as an important variable when looking at these three response variables. So yeah, and we did many iterations of these and tested interactions. So vessel type, essentially crossing vessel type and species. So if there's a whale, ecotour boat and a killer whale, does that influence distance more? Yeah, there were many iterations of these, and vessel type did not show up in them, which was surprising. And this again may iterate the importance of education programs, that recreational boats seem to be very aware of these regulations in northern Vancouver Island. And again, this was quite a big difference between studies done in the Salish Sea. And although the studies in the Salish Sea did not do these mixed effects models, they just did the compliance study. But yeah.
Awesome, thank you. Now a question for Joanne. I keep mixing it up, to keep everybody engaged. This is a question from Jan. Are there other marine species with recovering population that are being studied? Are there common factors under consideration? So do you know of like similar work, Joanne, that's being done on other species in the area?
In terms of ecosystem modeling, there has been many different studies. Unfortunately, they're mostly on southern resident killer whale, so it's not necessarily a recovering species. In terms of diet, there is, from my knowledge, well, killer whales have been extensively studied. There is always ongoing information, it's always ongoing pre-collection or trying to find these foraging behaviors. So yeah, I would say for me, that's my only knowledge, but it's also the only 2 species that I have personally worked with and that I know people who work with them. So maybe Jackie and Felicia know a little more about it.
Thank you so much, Joanne. One more question for you from Jillian. Sorry if I said that wrong, by the way. It is late and I'm French Canadian, so I do tend to say things wrong.
French Canadian.
I'll use it when I can. What kind of time frame was used for taking samples for the isotope analysis? Is density and diffusion a concern?
I'm going to say I am also French Canadian and it's also late. Jillian, you sound like a chemist. I am not sure if I understand your question correctly. In terms of time frame, for the sampling, it was done the day of, and I'm taking this in a chemist direction. So if I am mistaken, just let me know and I will restructure. But the samples are kept on dry ice. Sorry, so automatically at over minus 80 degrees, and they are always kept in such environment, which is to preserve not only the stable isotope, but also the many other things that are done with these samples, including hormones and lipids. So in terms of, yeah, if that's what you are referring to in terms of time frame for samples, I would say they're preserved in a almost pristine way so that we can get all of the information that we need.
Thank you so much. We have about 5 more questions, sorry, about 5 more minutes, folks, wanting to be respectful of the time that will end at 8:30.
Yes, and as we're kind of like nearing the end of the presentation, I think first and foremost, I want to reinstate how important the work that the research associate Joanne and Ali did, not only in the context of their own research, which is fantastic and like a amazing feat in and of itself, but also in informing other MERS projects that we're working on right now. Jackie mentioned the boater course. We're looking at site fidelity. So this is very much like the beauty of science, right? Like you did a big chunk of work, we collaborate together, and we're very excited to see where that work's going forward. So just like big, once again, hats off to the both of you for moving science forward. And do you have, like, we're at the end of the day now, do you have like a 1 sentence or just like a take-home message that you really want to highlight before ending the webinar today? We can start with Joanne and then Ali. So sorry, that's very rude.
Ali's muted. She's like, 1 sentence. I think Jackie and I have talked a lot about this, but how important humpback whales are, but also how much they have different personalities. Like they're all unique individuals and they all have, as we mentioned, like unique feeding strategies and diet and all of that. Yes, that is region dependent, but it just highlights the amazing nature of the species. And yeah, I'm happy to hear about all the research that is coming forward, and I hope I will continue to be part of it.
Thank you so much. Ali, do you have parting words?
Sorry, I was thinking there when I was leaving myself muted. Yeah, great question. Parting words. I think from this project and research, and just the, I don't know, the sign of the times. It was really great to see the potential associations with viewing, because a lot of the research that I read and prepped for in literature review is seeing negative behavior can push forward negative behavior, essentially. And it was really, yeah, parting words is that positive behavior can also push positive behavior. Um, and yeah, just that if you see someone doing something positive, then there's a chance you may follow too. Or yeah, if someone sees you doing something pro-environmental, whether it's putting out your recycling, whatever, or staying farther away from a humpback whale, they might follow your actions. So yeah, I found that really empowering and hopeful as the kind of end outcome of this project.
Maybe Felicia, I'll thank people and you thank Ali and Joanne, but everybody who's on the call, thank you so much for taking the time with us. And I think very much like attached to what Ali just said is by you knowing more, you're helping as well. So thank you so much for having the time with us, and we will put a recording on the website as well and announce that on our social media.
Thank you so much, Ali and Joanne, for the wonderful research, for taking the time to share it with us tonight. I had seen this research before, but you always get a bit more every time. So I encourage everyone to look at the recording again and stay engaged with science.
Thank you, everybody, and good night to you all.
Thank you. Thanks again, MERS, for having us. And thank you for everyone.
Yeah, thank you for joining, and thank you, Jackie and Felicia, for hosting this.